Hello again. Still on number 1, now we're going to move to part B. How many cars can enter the parking lot from time t equals 0 to time t equals 12? Give your answer to the nearest whole number. All right, let's see if we can focus that up. To the nearest whole number, the number of cars entering the parking lot from time t equals 0 to t equals 12 is determined by accumulating or using an integral on the entrance rate. So we are going to track the accumulation of the entrance rate from 0 to 12 with respect to time. And we can do that right from the calculator because this is a calculator problem. So we're going to go back to our math button. So we press math. I'm going to scroll down to FN integrate, function integrate. And I have to go through the same slow process that I did for nderive because again, I don't have an updated operating system here. But when you have the updated operating system, it prompts you for the function, the variable, and the endpoints. So I'm going to go and retype this. 30 plus 5, x minus 2, x minus 5, e to the negative, and I press the correct negative button this time, 0.2x, comma, with respect to x, comma, from 0, comma, to 12. This is what you used to have to do. And let's see if it works. So we're looking at a grand total of 520 cars. Now, if you want to put the decimal, that's fine. But we're talking about the nearest whole number here. So actually, it's not fine. You do have to just say the nearest whole number because you can't have 0.07's worth of a car. 520 cars enter the parking lot from, now I'm being a little generous here. It doesn't require me to interpret it, but I am. 520 cars enter the parking lot from time 0, I'll put t equals 0 to t equals 12. And if you want to, here's some extra detail for you. Time is measured in hours after 5 a.m. So from 5 a.m. to, let's see, 5 plus 12 is 17. Is that 5 p.m.? Oh yeah, duh, 12 hours. So that's looking at part B, very quick and easy to answer. And in case you're wondering, part A, 1 point, that's it. Part B, 2 points. 1 to have a correct representation of the integral, understanding and proving that you got 520 honestly. And then a 2nd point for the correct final answer of 520 cars. So all of this is just extra and not point worthy. All right, we're going to roll into C. We'll do this together. Okay, part C, use a trapezoidal sum. Oh, how fun. Let's first really quickly make sure we have the correct formula for a trapezoidal sum. That is height divided by 2 times the sum of the 2 bases. Now, here's the catch. In calculus, our trapezoids look sideways. Okay, in calculus, our trapezoids look like this, where our 2 bases are actually vertical bases, b1 and b2. Those are the y values of the function. So if we start at A and end at B, f of A is b1 and f of B is b2 because that is the height at A and the height at B. And then the width between them is what we call the height. So our trapezoids in calculus are actually vertical ones. So just make sure you need it if you need to change that orientation in your mind. So to approximate 2 to 12 of L of t, we're going to be using the table and we're going to be using this trapezoidal formula. And it specifically says 4 sub-intervals. So I'm going to put the table back into view so we can see it. And if we mark this up, 4 trapezoids will be between 2 and 5, between 5 and 9, 9 and 11, and 11 and 12. So my first trapezoid between 2 and 5, well, that's a width or a height of 3. So 3 over 2. And then first base 15, second base 40. There's my first trapezoid, number 1. Number 2, between 5 and 9, that's a width of 4. And the 2 bases are 40 and 24. Okay, next trapezoid between 9 and 11, that's a width of 2. And the 2 bases are 24 and 68. And then finally, between 11 and 12, that's a width of 1. And the 2 bases are 68 and 18. All right, almost went off camera there. So there's the setup using the table. Let's see, do I need to do anything else? Okay, using correct units, explain the meaning. So this is the accumulation because we are accumulating the rate of departure. So our units here are going to be, this is the number of cars leaving the parking lot from time t equals 2 to time t equals 12, or from time 7 a.m. to 5 p.m. The number of cars leaving the parking lot was, and then we'll go ahead and say our answer. Well, to be honest, I'm just gonna put this in the calculator. Let's do 3 over 2 times 15 plus 40 plus, no, I'm just gonna do 2. 40 plus 24 plus 2 over 2 is 1, so I don't even need that. 24 plus 68 plus 1/2, 68 plus 18. All right, so we are looking at a grand total of 345.5 cars. And I'll go ahead and actually interpret this integral instead of the number of cars, because I know what cars are. All right. So 2 to 12 of L of T dt is the number of cars leaving the parking lot from time t equals 2 to t equals 12, or 7 a.m. to 5 p.m. Now, of course, you can interpret that in a couple of different ways, but the big key ideas or the big key points are noun, units, time. Noun, number of cars, units, well, I should have said hours. I guess implying hours is here. So I'll go ahead and check that. See, if you think through noun, units, time, that kind of checks you to make sure you, oh yeah, my units were hours, and then time, t equals 2 hours, so t equals 12 hours, or 7 a.m. to 5 p.m. Okay, I'm gonna take a break here, and then we'll pick back up with the last part of this problem.